So today is going to be a quick recap of the index laws and how they all work with Euler's number E. So, as a reminder, we have about 6 index laws. We have a few that look like this. So if we have a to the m times a to the n, this becomes a to the m plus n. If we have a to the m over a to the n, meaning divide, then that becomes subtraction of the powers. If we have a to the 0, that's equal to 1, with one caveat that a cannot be equal to 0 as well. So one restriction on it. As well with this, we also have the power of a power. So if we a to the m to the power of n, well, that's just a m times n, or mn for short. If we then have a to the m on n, well, the on n represents the radical, the nth root of a to the m. Or we can also write this as the nth root of a all to the power of m. So these are 3 different ways of writing the same thing. The last rule is the negative rule, which is that if you have a to the negative m, well, you can write that as 1 on a to the m. So these are about the 6 index laws that we work with most of the time. You can write a few other ones, but they're usually just rewritings of the ones we already have. So here are our index laws. Let's play around with the index laws, make sure we're feeling comfortable with them. So for our first one, let's just check a nice one. If I have e to the 3 times e to the 4, this would be equal to e to the 3 plus 4, which is 7, using the first index law. If I have e to the 6 all to the power of 2 over e to the 5, well, this would be equal to e to the 12 by the 4th index rule over e to the 5, right? Because 6 times 2 is 12. If I then wanted to combine this further, well, the division becomes subtraction. So I'd get e to the 12 minus 5, which is 7. And just for a nice little complex one, if I have root e times e to the 3 over e to the 5, well, this one's going to take a little bit more working out. So root e is better written as e to the 1/2, because remember square roots are second roots, times e to the 3 all over e to the 5. Alrighty, from here, what can I do? Well, I want to add a half plus 3. Now, you might be tempted to make it a mixed fraction, 3.5, or a decimal, 3.5. But I recommend for powers that you always keep things as improper fractions. So m over n makes it look nicer. So in this case, a half plus 3, well, 3 can be written as 6 halves, and so we get 7 on 2 over e to the 5. Because a half plus 6 halves is 7 halves. Once again, we run into the same problem, but with subtraction here. 5 isn't written in halves, but 7 on 2 is in halves. So 5 is better written as 10 halves, and 7 halves minus 10 halves is equal to minus 3 halves. But that's not a very nice thing to look at. There's 2 issues with that. The first is the fraction, and the second is the negative. And we're going to deal with them in the reverse order, meaning let's get rid of the negative first. So this is better written as 1 over e to the 3 on 2 by the 6th index law. And using the 5th index law, we can write e to the 3 on 2 as its nicest form, which is 1 on the square root of e to the 3. And that is simplifying that 3rd example. So we started with that at the top, and that's where we ended up. So just make sure you're feeling comfortable with the index laws, because we're going to be using them a lot next time.